Hey everybody, I am still working on the GeoFiles episode that's going to have this in it. Sorry, I'm got a lot of other stuff to do. This is Geo-Rant 118. It is January 10th, 2019, times about 14:30 CST. I'm out in the Geoshed, and it's 50 degrees Fahrenheit out. That's 10 Celsius, plus or minus. And I'm at like pretty close to 42 degrees north latitude in North America. It should not be this warm on January 10th. It's 2020. Yeah, it's the 20s again. I guess should I go to a speakeasy or something, you think? But anyway, what am I going to talk about today? Well, I'm going to talk about a certain publication because, as you guys know, I have a lot of Illinois State Geological Survey bound publications. In the early days, they were bound hardcover, green or red. This particular one, happy 100th birthday. I don't know exactly when it was published in 1920, but it was published in 1920, although most of the information is from a couple years earlier. But I wanted to show you this for other reasons as well. What is in this publication? There, other than a bunch of oil and gas data and stuff like that, is this book was the first serious attempt to define what we call the Lasalle Anticlinorium, which is this huge feature in Illinois. It basically runs from north central Illinois all the way down to southern Illinois in the Illinois basin. In northern Illinois, it's Paleozoic. All the rocks are Paleozoic. You see this behind me. I'll get to here in a second. It is probably the most distinctive feature in northern Illinois. It has the greatest dips, strikes and dips of any unit. All right, in northern Illinois. Most of the geology, most of the Paleozoic rocks in Illinois, on a local scale, are flat-lying. Less than 1 degree dip. Ultimately, on a large scale, they do dip towards the center of the Illinois basin in southeastern Illinois, southwestern Indiana, where they do thicken a little. But on a local scale, up to several dozen miles, they're essentially flat-lying with relatively consistent thickness outside of where there are angular unconformities, which were represented by erosion. But this, like I said, was the first attempt, and I can't believe how well preserved this is. Some stuff in here is from Yearbook 1916. Oh, by the way, this is bulletin number 36, I believe it is. So it is one of the very first ones, just so you know. That's what it is. This was back when they would consolidate papers, and there was interest in the Lasalle Anticlinorium for economic reasons. Twofold, which I'll get into here. Actually, I'll just tell you now. You had the Ordovician St. Peter sandstone, which is a very well sorted, very pure quartz arenite sandstone. It is mined for glass. It's the world standard for sandstones. We compare everything else in the world to this. It's also one of the major aquifers in Illinois. And then we have the Pennsylvanian coal above it. And in the early days, they thought there might have been some gas associated with it. Turns out there really isn't. Nothing economical. But the thing with this is back in the day when they would just put these huge plates in there. I mean, the paper is very thin. And this book, before it came into my hands, somebody was retiring and getting rid of all their old publications. It came, They must not have looked at it very much. And I love this one. This is perhaps my favorite because this was one of the earliest attempts to address the surface of the St. Peter sandstone to try to get its depth relative to sea level. And as you can see here, so here you have Illinois. You can see how many bumps here. The Lasalle Anticlinorium basically extends from about here. The north end is marked by something called the Troy Grove Dome. And actually a lot of earthquakes in Illinois, that can be felt and will wake you up. There was one in 2010 that woke me up. happen on that dome, but it runs down this way and comes down here before it peters out in the deep part of the basin. And here's more local, the Oglesby area. It's close to Starved Rock, for those of you that know where Starved Rock is. There's some drill holes done. Here's the Illinois River. There's the Vermilion River. The Vermilion River is where Mathiasen State Park is now. So this book has a lot of little information in it. And it was really the thing that got going on this finding the Lasalle Anticlinorium. The best exposures in Illinois of the Lasalle Anticlinorium are in Mathiasen State Park along the Vermilion River. And the beds dip. You get out there. Actually, I'll link a video I made like 10 years ago below where I'm actually in the park showing you this stuff. You see rocks angled and it looks like they fell that way. They aren't. They didn't fall. That's their natural position. You see dips in the rocks of greater than 30 degrees. So what happened there? Well, basically this is the modern scenario. This is a cross-sectional view, not to scale. This would be the axis of your... It's called an anticlinorium, not just an anticline. Quite honestly, in most places, it's almost a monocline. But it's called an anticlinorium because it's not consistent in its axial range, and the thing is huge. So this is about your axis right here. And dips, this would be your north. All right? Vertical exaggeration here is, I don't know, 2 times, something like that. About, it's probably more than that. I'm not going to get into detail on that, but that's your north. And this, the north end of the anticlinorium dips very slightly. I think it's less than 5 degrees. It's stuff to this. Sorry, that is not north. That is east. My bad. So the stuff to the east, the dipping beds of the east, are less than 5 degrees. To the west, they're greater than 30. So what you have here is you have your Cambrian, which I just left as undivided. It's not exposed anywhere in the area. These are unconformities, erosional. Right? OA is your Ansel group. Your Ansel group includes things like, well, it's dominated by the St. Peter sandstone. But in Illinois, at the bottom, often filling these old valleys, here you get what we call in Illinois the crest. In Wisconsin is more appropriately called the Reedstown. So that's called the crest that fills these, and it's basically like little conglomeratic, shaly stuff like that. And then the St. Peter, the main part of St. Peter, like I told you, was a very clean quartz arenite. And at the top, there also is a minor unconformity on top of the St. Peter. I didn't really put it in here because it was more of a hiatus than deposition, because outside of the area, the top of the Ansel group will be represented by the Glenwood Formation. Sorry, and the Glenwood Formation can be meters upon meters thick, but in the area of the Lasalle Anticline, if it's even present, it's only a couple meters thick, and it looks like it's stream deposits, like the St. Peter experienced a period where the seas retreated, they regressed, and you started to get a little bit of stream induration on there, and then they came right back in. So it's not a major unconformity, not a relatively major unconformity, so I haven't had it here. Between the Cambrian and the Ordovician seas, you have this division of sequences. There's probably several million years. So this is probably 1, maybe 2 at the most, if that. So anyway, all right, that's the modern scenario. How did this form? Well, let me get the units first. So Cambrian undivided and cell grouped include the St. Peter, which most of it is. Ordovician Galena Platteville, Silurian plus Devonian undivided. This is carbonates and shales. And on top we have our Pennsylvanian, which locally is mostly, there's a beautiful cliff of Pennsylvanian sandstone with beautiful fossils in it on the cliffs of the Vermilion River, but it's so unindurated that you can't, it just crumbles when you grab it. But anyway, it's sandstones and shales, but there's one of the thickest coals in Illinois, the Colchester, the old number 2, is here. Right, and it's generally close to the bottom, and it's It's between half a meter and a meter thick, sometimes a little bigger than that. So 2 to 4 feet thick, something like that. And the point of them doing this was to see how economically viable it was. And the coal can burn. I've taken bits of the coal chester and gotten it hot enough to make it burn. So you can make it burn. Anyway, one here. Originally what we had level ground. We had our Cambrian here, which was mostly actually carbonates, the Potosi, Dolostone, that kind of stuff. The upper Cambrian in Illinois is not sandstone, all right? And it's really thick carbonates. So the seas had retreated, and you started getting erosion. They didn't retreat too far because we don't get massive paleotopography on this stuff, but we do get enough in places where it was, several meters of erosion. Okay, time goes on. The Lasalle Anticlinorium starts to fold. We start to get compression from the east and the west. Stuff starts to lift up as I wrote a Q there, that's a no, as the Galena Platteville was being deposited. How do we know that? Well, if you watch the video that I'll link below, you'll see the Platteville at the base on top of the St. Peter is what we call slide breccia. You look at the rock, and what you'll see is stuff like, it will look like the rock fits together, and this will be gray, and in between the gray is like this orange stuff, which is also carbonate rock with maybe some minor clastics. They call that slide breccia. So it kind of looks like this in the rock. What that means is as this was being deposited and as compression happened, this anticline started to form. Obviously, there would be earthquakes. Things would shake. Stuff would slide apart. All right? And then become filled, and in between would fill with other stuff. All right? So we know it started forming then. Well, we get down here. Compression continues. All right, now we start to get the Silurian and Devonian. The Silurian and Devonian is known in the area, but only from water wells. It's not exposed on the surface. All right, I'll get to the surface, what is exposed on the surface when I get there. So the Anticlinorium continued to form. All right, then it stopped for a little bit. All right, erosion took place. And by the time the Pennsylvanian came around, I don't think there's any Mississippian in the immediate area. There might be a little bit. Not by like Star Rock and Mathiasen. The Pennsylvanians started to be deposited on top of all this. And the Anticlinorium became active again. So what your bed, like if you have, let's say this is our Colchester number 2, you're going to have some initial dip. Because as this was being deposited, an uplift continued. Sorry, that's supposed to be a straight line. Beds are going to conform to the topography. Remember, the law of superposition only holds if the beds are undeformed. These are not undeformed, all right? And after the Pennsylvanian, it stopped. There's some glacial deposits on top and stuff like that. There's erosion. Basically, what is exposed, it's a Star Rock Mathiasen area, is basically, the Cambrian carbonates are exposed, but they're exposed on the north side of the Illinois River. But actually in the parks themselves, it's basically this. That's your strat column. You'd have your Ansel group, your Galena Platteville, and your Pennsylvanian. That's really the only Paleozoic rock that's exposed there. All right. So, is this thing done forming? Actually, no, it's not. A lot of the earthquakes that have happened and have recorded still occur on the Lasalle Anticlinorium. So, which means there's still compression going on. This thing is not done forming. Where's the compression? What's causing the compression? Well, quite frankly, it's large-scale stuff, continental stresses. We have the Atlantic Ocean widening from the Mid-Atlantic Rift. At the same time, on the west end of the continent, we have this battle going on. We have the East Pacific Rise, which, and the Basin of Range, which are an extension area, and we have subduction over there. So we've got this battle going on over there. So we've got extension and subduction. We've got plates rifting or plates moving apart and subducting on the west coast. We got stuff rifting, getting wider, the Atlantic Ocean on the east coast. So what's that going to do? Stuff's going to push and something's got to move inland. And this was already here. This is a good place. Folds and stuff that already exist are a good place to reactivate. All right, it's a lot easier. It's like it takes a lot less energy. For me, this is my Anticlinorium. It takes a lot less energy for me to fold this that's already been folded than it does to take it initially and fold it. Okay? So, I guess that's it. If you have any questions or comments, I believe everything in that. I didn't screw up at all. If you have any questions or comments, please leave them below, and I hope you learned something.